So next thing we're looking at is logarithms and logarithmic equations. So what we need to remember is that logarithms are basically indices. Okay, so it's a matter of so when we think about indices, we think of index laws. Okay, we've gone through that yesterday, and we've been working with index laws for the last few years. Okay, logarithms also have laws which are based on the index laws, because if logarithms are indices, then we should be able to just basically transpose them one to another. So let's have a look at how to understand logarithms. So let's look, for example, at this situation where we've got 2 cubed equals 8. Okay, so we've just got a basic equation there, an equivalence statement, where 2 to the power of 3 is the same as the numeral 8. We can write that as a logarithm statement, okay, which, written as a logarithm, says that 3, our power, is equal to the logarithm to base 2 of 8. So we see here with our exponential equation here, we have our base, which is 2, okay, that forms the base of our log. Okay, so when we've got a logarithm like this, we can kind of ask ourselves the question: 2 to what power equals 8? Right, so when we've got a statement like log base 2 of 8, what it's really saying is this number 2, what number do we have to raise it to in order to get this number 8? And of course we know that the answer is 3, so log base 2 of 8 is equal to 3. Okay, so what that means is we can write a general statement, okay, for exchanging or rewriting the one form into another form. So if we have it in index form like this here, a to the x equals y, we could rewrite that as a logarithm, and it would be log base a, so the base in this power goes to the base of the log base a of y is equal to our power x. Okay. The logarithm function with base a is what we call the inverse of the exponential function with base a. And we can we'll be able to see that a little more clearly when we are looking at the graphs of them. All right, so let's consider the expression log base 2 of 16. So we can find the numerical answer to that by asking a similar question we did with log base 2 of 8. Log base 2 of 16 means what power of 2 gives 16, or 2 to what power gives us 16. And we know that 2 to the power of 4 equals 16, so that means log base 2 of 16 equals 4. So let's have a look then just at a couple more examples. What would be the answer to the first one? Log base 2 of 32. Yeah, okay, because we know that 2 to the power of 5 equals 32. So that's 5. And for the next one, 4. Yeah, okay. So we can go, I mean, you could just work your way through it if you're not sure and think, all right, 3 times 3 is 9, so that's squared, times another 3, that's cubed, that's 27, times another 3 gives 81, so that's 4. Okay, so that's logarithms in terms of understanding what a log is. But as we said, logs are another way of writing indices, and so we know there are index laws. So let's have a look at the laws for logarithms. they are related. So we know that when we have two numbers with the same base multiplying together, we add the indices. Okay, that relates to this first log law, and that is log to some base, okay, of some two numbers being multiplied together, so m times n. We can split that into two separate logarithms, log of m plus log of n. So here's this sort of connection where we're adding two logs. We can combine them to give us a single log where those two numbers m and n are multiplied. So that relates to the a to the m times a to the n equals a to the m plus n. Okay, so that's our first log law. The next one is the logarithm of a quotient. So if we are dividing, so log base a of m divided by n, okay, we can split that into two logarithms where it is the log of the top number, the numerator, minus log of the denominator, and vice versa. So if we've got the two separate and we want to bring them together, then we can do that. So we can go both ways, okay, because sometimes it is useful to actually combine them into one. Okay, and then we have the next one, which is the logarithm of a power. So log to some base of m to the power of p. That power can come out the front and multiply by the logarithm. So log of m to the power of p is equivalent to p times log of m. Okay. And this one here, the last one that we see there on that page, is log base a of 1 over m is equal to the negative log of m. And the reason for that is we consider this as a quotient, okay? That could be written as log of 1 minus log of m. And as we'll see on the next page, that log of 1 is equal to 0. Okay, so that becomes 0 minus log of m, which we can just write as negative log of m. Okay, so that sort of leads on to these last couple of important results, is that if, well, this one here, okay, that we saw just before, okay, regardless of the base, log of 1 is equal to 0. Now, if you kind of think about that, okay, in terms of our index laws, if I rewrite this as in index form, okay, that would be a to the power of 0 equals 1. Okay, so regardless of the base, when we raise it to the power of 0, our answer is 1. So that as a logarithm, it's saying log of 1 is equal to 0, regardless of the base. And the other one here is log to some base of that same number as the base is equal to 1. Okay, because if we write this in index form, a to the power of 1, so there's our base, a to there, to the power of 1 is equal to a. So regardless of the number, okay, 5 to the power of 1 is 5. 10 to the power of 1 is 10. Okay, so as a logarithm, log a of a, so log base 5 of 5 is equal to 1. Okay, so it doesn't matter what the base is. If it's logarithm of the same number as the base, it's equal to 1. Okay, so they are some important results. These log laws are on your information sheet. Okay, so using those log laws to do some simplification, okay, of some expressions. Okay, we'll do it with these. Notice that each of these logarithms in this problem all have the same base, and that's important. If you're simplifying a logarithm and you wanted to combine them, you need to have the same base. Okay, so log 2 times log base 10 of 3, okay, plus log base 10 of 16 minus 2 log base 10 of 6 over 5. What we can do here is we could combine those to a single logarithm, because we've got this plus, that can be combined where we're multiplying those two numbers together, and because of the minus, that would become the quotient. Now, before we do that, because we've got these numbers out the front here, okay, then what we need to do is to just change them. We can't do it while those numbers are at the front multiplying. So the 2 log base 10 of 3 we'll write as log base 10 of 3 squared. Okay, or we could write it as log base 10 of 9. Okay. So that's log base 10 of 9 plus log base 10 of 16. And the other one here, we have 2 log base 10 of 6 over 5. Then we'll do the same thing. Okay, so we can write that as log base 10 of 6 over 5 squared, which we'll square each of those. So that would be log base 10 of 36 over 25. So we have to square both of those numbers in the brackets. So instead of the 2 log 6 over 5, we'll write that as minus log of 36 over 25. So what we can do then is combine those. So that would be log base 10 of, so 9 times 16. And because we've got the minus, that will be divided by 36 over 25. Now, what we'll do is, so that's 9 times 16. What we can do there is multiply that by 25 over 36. And if we can simplify that a little bit, so the 9 into the 36 goes 4, and then the 4 and the 16 will replace to be a 4. So we've got in the end log base 10 of 4 times 25, which is 100. So log base 10 of 100. So it's good to then think, well, can I simplify that even further? What would log base 10 of 100 be? Think back to the definition. Yep, it's 2, because it's asking 10 to what power gives us 100? And it's 2. Looks like you're about to be interviewed.
Does anyone recall that?
Okay, solving equations where we have logarithms involved, okay, often requires us to use the log laws to change things up and simplify them a little bit. Okay, let's look at a few. So log base 5 of x equals 3. Okay, what we need to do is we need to extract that x out of the logarithm. Okay, and the only way to do that really is to change it into an exponential equation. Okay, so let's rewrite this. What would this look rewritten?
5 to the 3 is equal to x.
Yes. Okay, so the base of the logarithm is the base of the power. Okay, so x will equal 5 to the power of 3, and we can get a number for that. It's 125. Absolutely one.
Actually, that makes sense.
Okay, next one, same deal, right? Except it's going to be, so it's the log base 5 of everything in that bracket, those brackets, 2x plus 1. So that'll be 2x plus 1 is equal to our base 5 to the power of 2. Or 2x plus 1 equals 25. And we can just solve for x. To give us 12. Okay, these next two here, yeah, we've got two separate logarithms. So what we need to do, because we've got x's in both of them, we're going to have to combine them to just have a single logarithm. Okay, so then we can go and do what we've done with the first couple of examples. So using our log laws, okay, it's log of 2x plus 1 minus log of x minus 1. So with the minus there, we can rewrite it as a quotient. So that's log base 2 of first one goes on the top. So 2x plus 1 on top of x minus 1 is equal to 4. Okay, so now we can rewrite that in our index or exponential form. So 2x plus 1 over x minus 1 is equal to our base 2 to the power of 4, which would be 16. So we want to, okay, I've seen it in some of the exams marking, you can't cancel here these points. Okay, you can't just cancel out the x's, or I think I saw something similar where somebody cancelled the bottom x with the 2 on top because they're thinking, oh, there's 2 x's and so we can cancel. Can't do that. What we need to do is multiply both sides by x minus 1. So we end up with 2x plus 1 is equal to, that'll be 16x minus 16. So that's 17 then if I add the 16 and subtract the 2x. So x will equal 17 over 14. Okay, similar for this next one here, okay? So we've got log base 3, x minus 1 plus log base 3 of x plus 1 equals 1. So we can combine those, but this time because of the plus between the logarithms, we're going to multiply. So that's log base 3 of x minus 1 times x plus 1 equals 1, which is log base 3. That's a difference of 2 squares, so it'll be x squared minus 1 equals 1. And now we can rewrite that x squared minus 1 equals 3 to the power of 1, or 3. Okay, I'll pause for a minute. Okay, so then adding the 1, we get 4. So x actually will be plus or minus 2. Okay, did you remember that one, Aaron?
Yes, I did.
Good job.
What? You got it. No, you don't have to plus and minus. Oh.
Okay, now plus or minus 2, which so that there are our possible results. Now the only issue here is that what we need to do is check that they're valid. And I'll explain that in a minute. If I do log base 3 of positive 2 minus 1, that's okay, that's the same as log base 3 of 1. That's fine, that is actually the value, okay, that would be 0. But log base 3 of negative 2 minus 1 is log base 3 of negative 3, which actually is undefined. Okay, you cannot find the logarithm of a negative number. Okay, logs are only defined for values greater than 0. Okay. Oh, no, sorry, it's from here. X equals 2 is the only solution. Because if x is equal to negative 2, it's undefined. Okay, any questions? Okay, so exercise 14F, you can work through.
So,